Hello everyone, my name is Nael. I'm a computational journalist and the creator of Code Like a Journalist, a free online course about data analysis and data visualization with TypeScript. Today we're going to talk about functions. First, as usual, if you want to know when new lessons are available, subscribe to the newsletter, add a star to the GitHub repository, or subscribe to this YouTube channel. So let's open VS Code. I can also make this bigger. Go. So let's start by opening a new folder and create a main.ts file and a dino.json file. Here we go. And I'm going to hide the sidebar. If you want to hide the sidebar, you can use your cursor or you can use Command B to hide it, to toggle it. All right, so let's do a first console log hello, and we can run it with dino watch check dino run watch check main.ts. And so now every time we will save main, the code will be rerun. Functions. So functions are great to reuse your code. And the syntax is pretty simple. We have an example over here. So here we have a function, say hello, that logs hello. The syntax to declare a function, to create a function, is to use the keyword function. Then you need to add the name of the function. We have brackets. We will talk about what we're going to put in it in a minute. And then we have curly brackets with the code that will be actually executed by the function. So here, for example, the function is just logging hello. If you save this file, you see that nothing happens, and you have a yellow warning saying that hello is declared, but its value is never read. Basically, you created a function, but you're not using it. To use function, you need to trigger them. You need to call them. And to do that, you type the name of the function with brackets. And so now you can see that say hello logs hello. This here is the function declaration. We're creating it and saying, hey, this is what you're supposed to do. And now we are calling the function. So when we do that, the function here is created and kept in memory, in your computer's memory. And when we do this, your computer goes back to, hey, what is this function supposed to do? Oh yeah, okay, it's supposed to log hello, so I'm calling it. Of course, it's the same for variable names. Function names, try to keep them clear, simple, understandable. By convention, usually we use the camel case. So it's first word lowercase and then capitalized words for the following words. Yeah, since functions also are often doing something, we very often start our function names with a verb. For example, here this one logs hello, so we have say hello, a verb first to make it extra clear what it's doing. So the beauty of functions is that you can write code once and then reuse it everywhere all the time. So now, for example, I can call say hello as many times as I want, and it will re-execute the same line of code. Of course, here it's a very basic example, but when you have complex calculations and you wrap them inside a function, it's great because you can just directly call this function to do the computations as many times as you want. Parameters. So let's talk about the brackets. So in the brackets here, we can pass parameters. We can pass things that the function can use and that the function maybe need that the function needs to execute the code that is between the curly brackets. Sorry. So for example, say hello. We could add a parameter name, so the function would say hello to someone. So we can write name like this, and we need to say explicitly what is the time, the expected type of name. So you see that name here is created like a variable, but between the brackets. And then we are giving it an explicit type. We're saying name should be a string. Otherwise, we'll have an error. And so now we can use name like we would do with a regular variable, but we can use name just between the curly brackets, right? It's scoped. It's available just between this function curly brackets. And so say hello can receive a parameter name, and we can use it. So with backticks, we can say hello, $ curly brackets, name. So this is a template literal, and we are injecting name inside this string, and this string will be logged. So now the function hello expects a name parameter. But here you see that we have an error now, because we are calling hello without the parameter. By the way, this is called a parameter because we are inside the function, but here we say that we pass arguments. So our argument here could be Nael, for example. And now we don't have any errors, and you can see that the function is saying hello, Nael. So it's very useful. You can reuse code, but still with parameters, you can output different results with your functions. And yet this is called an explicit type. So usually so far in the code and the project that we did before, TypeScript, Dino was able to infer the types of everything that we were doing. But here we are creating a new function. So Dino, TypeScript, they have no idea of names type. So we need to help them out and say, hey, we want type to be a string. This needs to be explicit. And it's great because now, if you try to pass 2, you'll get an error. Argument of type number is not assignable to parameter of type string. We have an error because 2 is not text, and it would make no sense to have hello 2. We want a name, and names should be strings. So this is great type checking on parameters and arguments. It will help you avoid a lot of nasty bugs. Okay, so we've done all of this. And again, we can call this function now with different names. And you can see that we're logging hello, Nell, Emily, Diana, John, Jane. We can reuse the function, but this time with different parameters. Oh yeah, we talked about the type error. So right now we have just one parameter. Let me copy it in this. But you can have multiple parameters for a function. You just need to separate them with a comma. So for example, here our function say hello takes a first parameter name that must be a string. Then we have a comma. And then we have a second parameter, which is tired. And this needs to be a Boolean. So now we can play with both our parameters inside the function's curly brackets. If is tired is a Boolean, so this is true or false. If it's true, we want to log hello name. So the name of the person, you look tired. Otherwise, if tired is false, then we want to execute this line of code, hello name, you look great. So 2 parameters. You can have as many parameters as you want. Parameters could be strings, numbers, booleans, objects, arrays, even functions, dates, of course. Anything could be a parameter in your functions. And so now to call the function with both parameter, it's the same syntax. You pass the first argument, comma, and then the second, right? Nael, true. Emily, false. And so now you have Nahel is tired. You look tired. Hello, Emily. You look great. You're not tired because this is false. This is how you can use multiple parameters with functions. So now if we hover over the function's name, you see that we have its type description. We call that the function signature. So the function say hello, expects two parameters. So the parameters are between brackets. Name, which is a string, is tired. It's a Boolean. So this is exactly what we wrote here. But you can see that we have another type here. This is what the function is returning. And right now, it's returning nothing. We have void. And this makes sense. Right now, the function is just logging something. It's not returning something. But in real life, you want functions to return something. Sometimes you'll do functions like this one just to log something, but most of the time you want to give maybe some data to your function, and you want the function to transform it or clean it and to return the transformed or the clean data. So here we have another example. So this function here, convert dollars to euros. It expects a dollars argument, which should be a number, and it's returning dollars multiplied by 0.67. So yeah, the conversion rate when I wrote the lesson was 0.67. So basically when you have dollars and you multiply, this is Canadian dollars, when you multiply them by 0.67, it gives you the value in euros. It's the conversion rate. And here there's something new that we're doing. We have the return keyword. So the function needs a number, dollars. It do a calculation, and it returns the result of this calculation. So if we save this, you see that we have no errors, but it looks like nothing is happening. But actually, something is happening. It's just that the function converts dollars to euros is returning the value in euros, but we are not storing it anywhere, and we're not doing anything with it. So we can update our code like this. And so now we have the same function. You give it dollars, do the conversion, return it. Here we have a variable dollars, 100 Canadian dollars. And now we have a variable euros. Euros is now the result, the returned value of convert dollars to euros. We call the function, we pass the dollars. So now dollars is 100, we pass it to the function, and it becomes 67 euros. The function returns it, pushes it into the euros variable. And so now we can use euros, and we can do a console log. So this is $100 Canadian dollars is 67 euros. You have the result over there. If we update this, so let's say 125, we have the result of the calculation again, right? It works like this. The function returns the value. And so when you call it, you can put the returned value inside the variable. And then you can reuse this variable. And if you check convert dollars to euros, you see that it takes a number and it returns a number now. It's not void anymore. Because it returns a number, Dino and TypeScript, they know that euros is a number now. Since the function signature is typed, the return values are typed too. And so the variable here is typed as well. It's very convenient. All right, so this is about functions, basic functions, but it's not very convenient to keep all of your functions in the same files. Usually what I like doing is to create files for my functions and just call the files and reuse that. It keeps your code more organized and easier to debug, and also it's just easier to reuse your functions anywhere you need. Usually, we create a folder named helpers in which we put all of our functions. So create a new folder, helpers, and you can create a new file in it. And usually the name of the file will be the name of the function. This is just one convention that I'm following that I find useful and easy to remember. So convert dollars to euros, and this is a TypeScript file. So now we have a new TypeScript file inside helpers. I'm not going to be able to say helpers the proper way in this video, I think. So we have our new file here. And so now what we can do is grab this function declaration, we can cut it and paste it in there. All right. By the way, you can see in the VS Code, you can open multiple files at once. And you can also do something like this. Oh, no, not like this. If you want, you can also split your screen. So you can do a right click on the tab and say, oh, do you want to split left or right? So let's say that I want to split right. You can see that now I have the same file here on my left side of the screen. I can delete it. And so now I can work on two files at once. Pretty nice. I'm going to keep it just as before because I'm following the lesson. All right. So now we have, we need to import and to export the function. So first we need to export. So convert dollars to euros. So we cut and pasted the function declaration in there, and you can see that it's yellow because it's sitting in there, but it's not being used. What we want to do is to export it. So we can write export default function convert dollars to euros. So this tells Dino, hey, this is a function that is being exported. You can keep it, you can make it available to other files. And in main now, we can import this function. So we can write, usually imports are at the top of a file, convert, and as you start typing, you can see that VS Code is suggesting to you, hey, you probably want to import convert dollars to euros because this is what I'm seeing right now in your project. And this file is located in helpers convert dollars to euros, which is exactly what we want. So we can press enter. And now you have the syntax to import a function. Import convert dollars to euros. And you can see that now we have the function signature. It's the function that we created from helpers convert dollars to euros. So this function here now that we exported is now imported in main. And so it can be used directly in there. You can import functions in any files that you want. And by the way, if you are on a PC, maybe the slashes are in a different direction. I'm on a Mac here, so that might be different. Okay, a few notes about this here. So this is called a relative path. It's a file path, and it's relative because it starts with the dot like this. And this is saying, hey, main, start where you are. So this is the dot. Where you are in this folder test, in this project, you should be able to see a helpers folder. This is what we're saying there. in this helpers folder, you should be able to find a convert dollars to euros. So this is called a relative path. And from main, this is how we get to the function that we created. So now it works. We can reuse this function in any files that we want. Something that is really neat as well. Right now we are watching main, right? We did dino, run, check, watch main. When you do that, of course, the code on main is being watched, but all of the dependencies of main are also watched. So now, for example, if we switch this to 0.7 instead of 67 and we save, you'll see that Dino is detecting a change in one of main TS dependency, which is convert dollars to euros. It's a dependency because we are importing it inside main. So the file change is detected in that file, and then all of the code is being retriggered. Very, very neat. So when you start working with one main file and a lot of functions and scripts and code in different directories and files, watch will also watch all of this. Something that you can do too. So for example, let's say that you want to go directly to convert dollars to euros to the function declaration. You want to see the code of this function. Something that you can do is press Command and click on the function name. Maybe it's different on PC, maybe it's Control. And when you click on it, it will bring you directly to the relevant file. So when you start having a lot of functions, this is very handy. You don't have to go inside the Explorer tab, open a bunch of folders and try to find the file. You can just open it directly and it will bring you directly to the file. If the tab is not open, it will open it for you and it will directly bring you at the right place in the Explorer tab. Now, documentation. So documenting your functions is very important for yourself. Maybe we are going to reuse this function in 6 months and we won't exactly remember what it's doing. It's also very useful to document when you're using with other people so they can clearly understand what the functions are doing and maybe their limitations or things that they shouldn't be used to do. To do that, we can use GSDoc. Of course, we already have the type signature. It's pretty well, but still, we can add more information. It would be great to have some text and maybe an example. To use the GSDoc functionalities, you do a /2*, and you can see that now VS Code is suggesting a GSDoc comment for you. You can press enter. And it's already pre-filling some of the information that we can have in your documentation. Usually, this is what we do. So you have your documentation. Each line should start with a star. We have a sentence or two just explaining what this function is doing. So here it converts an amount of Canadian dollars to euros. And then we have our parameters. So here there's just one parameter and we explain what it's supposed to be. It's supposed to be the amount in dollars to be converted. And we also have the returns keyword. So what is supposed to be returned? The equivalent amount in euros. The reason why this is so handy is that this text here is perfectly understood by VS Code and by many other tools. So if I go now on my main, where we import the function, and I hover over the function, you can see the documentation. You can see the documentation over here. That's what we put in our function file. Very nice, right? If you don't remember what this is doing, you don't need to go check the file. You can just hover. You have the types, of course, as before, and you have the description. Something that we often do also in documentation is adding an example. So we can do it this way. So for the examples, we use the keyword example, and we use what we call a fenced code block. So when you use 3 backticks like this, and you can add a language right after it. So here I'm saying, hey, I'm creating a new block of code for the documentation. I'm opening with 3 backticks. I'm closing with 3 backticks. I'm saying, hey, this is TypeScript, TS. And here's the code I want to show in the documentation as an example. And now, when I check the documentation, you see that I have the sentence, but I also have the code example. And this is great. The syntax highlighting, the colors of the code example are the same as in the files. And if I need to, I can just copy this. Oops, sorry. If I want to, I can just copy this and paste it somewhere to get started. So this is something else that we do with functions. When we document them, we add examples if we can. Let's talk about arrows function now. So I'm going to remove everything in main for now, just to show you this other example. So when we create a regular function, I showed you, as I showed you before, we create a function with the keyword function and we give it a name, and then we can call this function this way, right? But there's another way to write functions, and it's a bit shorter. It's like this. We create a variable, we have an equal sign, and we say, okay, create a function that expects a name. We use the $sign and smaller sign to create something that looks like an arrow. And we say, with the name, I want you to do this. I want you to log something. Hello, name now. And then we can call that function as we did before. It will give you the same result as the traditional function declaration, but this is called an arrow function. Here, there is no real benefit to use it, but sometimes you just want a quick, small function to do something very basic. And when you use arrays methods, it's very often the case. For example, here we have an array of numbers. We have a function that checks if something is positive. So we have the number. If the number is greater than 0, this will be true. If the number is not greater than 0, it is negative, it will be false. So you can see that the function returns a Boolean. Oops. Returns a Boolean. And so now we are filtering these numbers with the filter method, and we are filtering them with the isPositive function. So the result is positive numbers, an array with just positive numbers. So that's one way of filtering values in an array with a function, because filter expects a function. That's what it needs. It needs to know, how do you want me to filter the values? This is how. This is the function that you should use that will return true or false. If it's true, keep it. If it's false, don't keep the number. But this here is a bit long, a bit verbose. We can do it shorter. We can make it shorter with arrow functions, like this. So we still have our numbers, we still have filter, but now we are using an arrow function in there, right? And you can see the arrow function is very short. All of our code is very simple now. We are using an arrow function inside the filter method. We're saying, hey, create a function that takes a number, and I want you to check if this number is greater or smaller than 0, and just return that. So the number here, it will start with -2. So num will be -2. -2, is it greater than 0? No, it's false. False is being returned. The number is not kept. Same thing with 1, same thing with 0. Oh, but now 1, num is 1, num is greater than 0. This returns true, so 1 is kept. And same thing with 2. So you see how arrow functions are making our code shorter. It's still very easy to understand. Another beauty of this is that numbers here is an array of numbers, right? It's typed as an array of numbers. So when we use filter, it knows, and filter with our arrow function, while TypeScript and Deno knows that there's only one possibility. It will be a number. There's just numbers in this array. So this arrow function will just deal with numbers. Arrows functions. We are going to use them a lot. Don't worry about it. And that's it for the lesson. So functions are super important in programming languages. They are obviously very important in TypeScript as well. They will help you organize your code, make it reusable, and keep it clean. And we're going to do a lot of things with them. If you want to dig deeper into functions, I also created a refactoring lesson in the Ninja Moves section. So you can see here you have the Ninja Moves section, and you have a link to the refactoring lesson. In this lesson, basically, we are grabbing the code we did for the savings account calculator project, and we are refactoring it by breaking it down into small functions to make it easier to understand and better organized and easier to debug. And that's it for this lesson about functions.